Hi again, Kirsten McDade here from Resources, and I am talking with Steve Germiat, who is a principal hydrogeologist from Aspect Consulting and has been working on this cleanup site for the last 17 years. Thank you, Steve, for joining us on this virtual tour. Can you tell me how Aspect Consulting has been involved with the GP West cleanup site over the years and what specifically your role is?
Yeah, so Aspect and myself personally, we began work on the site in 2004, originally assisting Georgia Pacific with preparation of the first feasibility study for this chlor-alkali area that was conducted under an older legal agreement with Ecology. Then we also conducted an environmental site assessment for the pulp and tissue mill portion of the site in preparation for GP's sale of the property to the port. And so once the port acquired the property from GP, they selected Aspect as the technical consultant to lead the port's MACA cleanup process under a new legal agreement with Ecology. And I've been Aspect's project management since that time, about 2008.
Thanks. This video is going to discuss how the area around the former chlorine plant area will be cleaned up. This is the area where the mercury contamination originated from. As Brian Gowan explained in the third video, a lot of cleanup has occurred in this area, and much of the heavily contaminated soil has already been removed and trucked away. But there's still mercury to be dealt with. And there's something else pretty interesting happening here, and I hope you can help explain it. The pH, which is the measure of acids and bases, of the groundwater here is very high, meaning it is alkaline or basic. And this actually has an effect on the mercury. Can you explain what the cause of this high pH is and how it affects the mercury present?
Yeah, so the chlorine plant historically produced both chlorine gas and also produced sodium hydroxide, which sometimes we may refer to as caustic, very high pH material. Both of those materials got used in the pulp production process for the mill, and they both actually got sold commercially as well by GP. Unfortunately, there were historical releases of mercury into the ground in this area. There were also releases of caustic into the ground in the chlorine plant area. And the releases of the caustic actually create the high pH, the alkaline pH that persists in the site groundwater today. The pH is really important because the solubility and the mobility of mercury in the environment increases at high pH. So it becomes more mobile in groundwater, for example. And in the high pH conditions, the mercury it's less attracted to the mineral surfaces in the aquifer matrix. Think of that as just the sand grains in the aquifer. And as a result, it stays in solution and it moves wherever the groundwater takes it. And so as you might imagine, the groundwater pH is highest in and around the historical chlorine plant where the caustic was handled, and no coincidence, the dissolved mercury in the groundwater is also highest in that area. And as you move laterally away from the chlorine plant, both to the south and the west, both the pH declines and dissolved mercury declines as well. I guess a little bit of good news is that these high pH conditions that create and drive the mercury into solution are actually reversible. So if we can return the groundwater pH to near neutral conditions, which is how it existed before the releases of caustic happened, the mercury will lock up into mineral forms and become much less mobile and also become much less volatile. I think one thing just important for people to understand is that unlike a lot of contaminants we deal with, mercury is an element. And because it's an element, we actually can't destroy it. But what we can do is change its form chemically and lock it up into mineral forms. And when it's in those mineral forms, it's much less mobile, it's much less volatile, and as a result, it reduces the exposure risk that the mercury poses in the environment.
Thanks, that is all really interesting. So then, what are the mechanisms proposed to address this high pH?
So the proposed cleanup action includes actively neutralizing the highest pH groundwater on the site. And specifically, the approach is to excavate a series of long trenches that will go down into the groundwater. And so we'll have these open trenches, and then we will backfill them with a treatment material that is specifically designed to reduce high pH, so lower the pH and buffer the high pH. And they're shown on the slide here as a series of long east-west trending trenches. And it's important to understand that the trenches with this treatment media in it will be permeable, which means the groundwater will be able to flow passively right through it. And as the groundwater moves through the treatment trenches, the treatment will be affected and it will neutralize the pH. And once the pH of the groundwater drops, the mercury will form mineral complexes on the aquifer materials, and therefore it'll be immobilized. And in total, there's more than about 1,000 linear feet of trench to be installed. And the trenches are parallel to each other in series, and the groundwater will actually pass through multiple trenches before it ever gets close to the shoreline. And these neutralization trenches are one form of what is commonly called a permeable reactive barrier. And that is a remediation approach that's been applied really over the last 20 to 25 years. And what makes them fairly effective way to treat groundwater is you can select the specific type of treatment media that goes into these trenches based on the type of contaminant that you're trying to treat. And it's referred to as a barrier. The barrier refers to stopping contamination, not stopping groundwater. And the image that's shown here is an illustration that EPA prepared to sort of help visualize the basic concept that's happening underground.
Thanks, that was really helpful to understand. In addition to mercury contaminated soil and groundwater, there's also petroleum contaminated soils, petroleum hydrocarbons particularly. Given these contaminants, what is the proposed cleanup for the soils and groundwater of this area?
Yeah, that's right. Mercury is the big focus for the chlor-alkali area, but there are 2 areas of petroleum contamination in the area. There's some fairly shallow contaminated soil within a small corner of the chlorine plant area. And then as well, there's also the million-gallon tanks area. And in that area, there's a plume of groundwater contaminated with naphthalene. And that's why you see the long elliptical shape. Naphthalene is a fairly simple organic molecule. It's actually quite degradable by microorganisms naturally in the ground. And the data we've been collecting over several years of monitoring indicate that that biological degradation is occurring and the concentrations of naphthalene in groundwater are declining over time. And we refer to that as natural attenuation. So the cleanup action will include monitoring to make sure that the natural attenuation is continuing until it meets groundwater cleanup levels.
In the draft cleanup action plan, it states that soils with visible mercury will not be disposed of. Can you explain why the decision was made to leave this contaminated soil in place? And can you also tell me what you say to people in general who express concerns about any of the mercury that is left behind?
Yeah, well, ecology determined that the incremental cost of excavating all of that soil, treating it, and then hauling it, some 350 miles to Eastern Oregon was disproportionate to the incremental benefit that would be achieved relative to the selected cleanup action of treating that material in place. And I would tell people that are concerned with that decision that really the purpose of any remediation is to prevent exposure of people and any organisms to the contamination. Ultimately, there's a lot of different ways to accomplish that goal, and that's really why you do a feasibility study in MATCA. It evaluates the full range of cleanup alternatives to accomplish that protectiveness goal, and it also then determines which alternative, when you run through all the criteria in the MATCA regulation, is what's referred to as permanent to the maximum extent practicable. And by law, that practicability determination needs to consider both the environmental benefit and the cost of achieving that benefit. So I guess, in short, I would tell them, despite leaving mercury contaminated materials in place, ecology's selected cleanup action will prevent the environmental exposures associated with those materials.
And speaking of this mercury left behind, do you have an estimate of the actual amount of mercury that will ultimately be buried or fixed on the site?
So there are a few areas to consider. We previously in previous stops discussed the ChemFix area, and in that area, We estimate there's about 22,000 tons of material chemically stabilized and capped in place. And then for the proposed cleanup action to come, we estimate, roughly another 20,000 tons of mercury contaminated soils will be chemically stabilized in place. In addition, roughly 6 to 7 acres of the chlor-alkali area contain mercury contaminated soils that will be capped. As you might expect, the areas being capped have much lower mercury concentrations than the soils that are going to be excavated or treated in place.
So it's my understanding that having elemental mercury at a cleanup site is relatively unusual. Is there any way to estimate how much mercury will have been removed from the GP site?
Well, we estimate that the prior two interim actions removed roughly 4,300 tons of mercury contaminated materials from the site, and we estimate that the current proposed cleanup action will remove another 12,000 tons or so. And it's not just soil, there's also a fair bit of debris that is mercury contaminated. That's old building foundations and whatnot. And so all of that will be included in the cleanup action as well.
Steve, in closing, is there anything else that you would like to add about the cleanup for this particular area that would be helpful or interesting for folks to know?
Well, this is certainly a very challenging site to clean up. It's as challenging as any as I've worked on in my 32 years of consulting. I would say, the Port Ecology worked for more than 4 years just on the feasibility study to arrive at the cleanup action that Ecology ultimately selected. And I'm, very comfortable with the outcome and that final decision. I think it's important to recognize the challenge isn't over yet. It will continue as we design the cleanup action and ultimately implement it in the field. So there's quite a bit of work left to do there.
Thank you so much, Steve, for taking the time to share your expertise and experience with us on this very complex and pivotal cleanup site. We appreciate the thoroughness and thoughtfulness that has gone into the cleanup effort so far and look forward to when the site is all cleaned up and is ready to be put back into use. In the next video, Eleanor will talk again with the Department of Ecology Site Manager, John Gunther, about the lignin parcel and site monitoring. So be sure to tune in for even more information in Stop 6.